Page 83. We are supposed to solve some problems. Number 1 says to find the area of each figure. So we're looking at this complex shape. This looks like the letter L. And again, there are different ways to do this. You could divide the shape up this way. And I think that's how I'm going to do it. You could divide it this way. However it makes sense to you. But for me, I like this way because the measurements are there and easy for me to see. So I am looking at two different shapes, and I'm going to color those for you so that I can talk about them without confusing you. So here we go again with this pen. Let me take the cover off. I'm going to try that one more time. So in this rectangle, I'm making it yellow just so we can see it and I can refer to it. Area is this inside space, and this is a rectangle. And then I have this little rectangle that I'll make blue. And to find the area of this thing, we have to add these two pieces together. So the area of the yellow one will be length times width, or 9 times 5, or 45 square yards. That is one thing you would want to check. And I did it, but I didn't say it. Always check your units and make sure that you have the same unit all around. That's very, very important. So this part is 45 square yards. And then I need to do this process again for the blue one. Length times width. Write that formula every time and you'll memorize it before you know it. So area is going to be 12 square yards. And so to get the total area, you have to combine those. One more step. 45 plus 12 is 57 square yards total. Number 2. And I'm going to turn off my landline. If you hear it making a noise, I'm just taking it off the hook, so bear with me. All right, number 2. I have a square and half of a circle. So for the square, I'm going to use area is length times width, or actually I'm going to use side to the second power. And so we have 8 to the second power, or 8 times 8. That's the same as length times width. And that's 64 centimeters square. And then we need to find the area of a circle, which is pi r squared. So area is pi times the radius to the second power. Well, I know that this is 8 centimeters. So half of that would be 4 centimeters. So 4 to the second power is 16. So we're looking at pi times 16, and I am going to use a calculator. 3.14 times 16. That is 50.24 square centimeters. But remember, we only have half of a circle. So we're going to have to take 1/2 of 50.24. And that all means multiply. That will give you 25.12 for this part. So we have 64 and then 25.12. And we need to add those two together. Again, I'm using a calculator. So I'm getting a total area of 89.12 square centimeters. And I'm going to put a box around that so we can find it easily. Same thing up here. I'm just going to box in my answer so that we can see it. All right, number 3. This one has a bite missing out of it, a triangular bite. And so we have a rectangle with a triangular bite missing. So I want to do the area of the rectangle, which is going to be length times width, or 25 by 20. And that is going to be 500, and this is square feet. And then I'm going to do the area of a triangle. So that's 1/2 base times height, or 1/2. Be careful here. Here's your base. It's parallel to that 25. So the base is 25 feet. And the height of the triangle is this line right there. That's 10 feet. So we're going to have 125 square feet. Let me just check that. I'm awfully tired today, so it's yes. And then we have to subtract because the bite's missing. So 500 minus 125 is going to be 375. And that is square feet. And that is our final answer. Number 4, we have you could do this either way. You could do it as 2 rectangles added together, or you could do it as a rectangle minus a smaller rectangle, minus a bite. I think I'm going to do it as, let me think. I'm going to use subtraction. I'm going to take the bite out of the big rectangle. But you could absolutely do it both ways. You could draw a line there and work it as an addition problem. But the big rectangle is 9 yards by 5 yards. Everything is yards. And so the big rectangle is 45 square yards. And then we have this section that is also a rectangle. That is 4 by 3 yards. So that's 12 square yards. And once you have square yards and square yards, you can subtract to take the 45, take the 12 away from the 45. So you're left with 33 square yards as your final area. Okay, this one to me looks like a triangle with a bite missing in the center. So I'm going to take my triangle, which is 1/2 the base times the height, or 1/2 of 8 times 7. Here's the base. The height cannot be measured on a slant. It has to be a perpendicular distance. So 8 by 7, and then we take half of that. So that would be a half of 8 is 4, and 4 times 7 is 28 square centimeters. And then I'm going to do the circle, which is a equals pi r squared. So a equals pi times half of 3, that's 1.5 squared. Be careful, radius is 1.5. So pi times 1.5 squared is 2.25 times pi. And I'm using 3.14. You can do the fraction if you want, but either way is fine. And this one is a subtraction problem because we have a bite out of the big shape. So 28 minus 7.065. And that's going to be 20.935 square centimeters. And that is your final answer. This one is definitely addition. We have a rectangle with a triangle on top of it. So I'm going to do this with the addition process. So we have the rectangle is length times width, or 25 by 20. And that is 500 square feet. And then we have a triangle that is 1/2 BH, or 1/2. I can tell you 10 is the height, and the 25 is the base. It's parallel to that bottom 25. Did I not already do this problem somewhere? It's close to number 3. I thought this feels the same. Number 3 has a bite missing. This one has an added piece on top. So it's the same math, but it's a different problem. So this is going to be half of 250, which is 125 square feet. And this time we don't have a bite out of the problem. We have two pieces put together. So we have 500 plus 125, and that is 625 square feet. Number 7. A circular fountain has a 3-foot walkway surrounding it. So this distance is 3 feet, and so is this one. These are concentric circles. What is the area of the walkway, or the blue part? Round to the nearest tenth. So we're going to find the area of the big circle, and then we're going to take a bite out of the middle of it. So the radius of this one is 3, and there would be 3. Be very careful. Let's do the bigger circle first. So we have pi r squared. And remember, the radius is the distance to the center. So for this big circle, let me highlight the radius for you. It's from the center to the edge of the circle. So the area is pi times 6 squared, or pi times 36, or 36 times 3.14 is 113.04. Then we need to do the process again for the smaller circle. And it is pi r squared. So the smaller circle has a radius of 3 feet. So pi times 9 will be, 9 times 3.14 is 28.26. And this is a subtraction problem. It kind of looks like that center bite is gone. You're only interested in the area of the walkway. So do that subtraction on your calculator. And it looks like 84.78 square feet. Number 8. An X is formed by drawing one 11 by 6 inch rectangle on top of another. What is the area in square inches of the X? So they want us to find the area of this thing. But we have to take out the duplicate. We don't want to count that area twice. So you could do it as 5 rectangles. That's absolutely doable. Let's put some dimensions in here and see if we can figure out another way to do it. So I know that this is 11 feet this way, and this is 6 feet, and there are two of those. So I could tell you that this is 6 feet, and this distance is 11 feet. So there are the 11s. You could do 5 rectangles. I'm going to do subtraction. I think I want to take the bite out. So here are all the rectangles. If you wanted to do it with addition, you would have to figure 5 of them or do some multiplying. But I'm going to take the full area minus this square because that's the duplicated part. We want one of those, but both rectangles, we don't need to double count this area. So we're going to have to figure out the dimensions of this square. Well, I know this is 6 feet. Let me take out that 11 because that's not the place I should have put that. This is a 6-foot square in here. So I'm going to do 2 of the 11 by 6s, and then I'm going to subtract out the 36, the square footage. So here's what I want to do. First, I'm going to do the rectangle. So I have area is 11 by 6, and those are in inches. I don't know where I got feet. That's a problem. I just made that up. But it's inches. That's in the problem. What is the area in square inches of the X? So this will be 11 by 16. 11 by 6, sorry. That's 66 square inches for each of those rectangles. This is for one. But we have 2 of them. So 66 times 2 is going to give us 132 square inches for the whole thing, the 2 rectangles put together. And let me try something here. I don't know if my iPad is going to allow this or not, so bear with me. I think it will. I'm going to color, let's use blue and yellow. I'm going to color this rectangle blue. So we found this area. 11 by 6 is 66 square inches. That's the blue part. And then I'm going to color the other rectangle, the full thing. It may not work. I'm hoping that middle will turn green. Color this one, which is also 66, but you can see that I'm double counting that square. You can see me coloring over it. Yeah. We want to subtract out the green because we counted it twice. So let's find the square inches for this square. So area is side to the second. 6 to the second. That's 36 square inches. And we want to subtract that because we don't want to count that space twice. We want to remove that overlap so that we're not doubling it. And again, you could do this problem lots of different ways. This is just the way it makes sense to me. So your final answer is this one, 96 square inches. I like that problem. The shaded area represents a walkway around a triangular garden. What is the area of the walkway? So we have a square that is 32 on one side. And if I do 32 squared, because it's a square, I get 1024 feet squared. And then if I do the area of the triangle, that is 1/2 the base times the height, or 1/2 16 is the base, and the height is 18. So the area here is 0.5 times 16 times 18. And that is 144 square feet. And we need to subtract here because there's a bite gone out of that big shape. So subtract those two, and you will get your final answer. 881 square feet of walkway. Oops. Number 10. An event planner has the following space to create a dirt bike course. To the nearest square foot, what is the area of the space? And it just occurred to me, I need to back up a second. Somewhere it told me to round to the tenths, and I didn't do that. Number 7, it said to round to the nearest tenth. That's my final answer, so I need to do that. Sorry, when I read those directions, it made me remember. So this would be 84.8 square feet. And I think I meant to round because I didn't put a box around the answer. But sorry about that. We need to make sure we're following that instruction. Okay, an event planner has the following space to the nearest square foot. What is the area of the space? So I have a rectangle, or a square actually, in the middle, and then I have 2 half circles, which would make 1 full circle. So we want to do the area of a square, and then the area of a circle, and add those together. So the area of the square is going to be 60 to the second power. 6 sixes are 36, and then we have 2 zeros. Those 3,600 square feet for that part. And then this one, we need to do area is pi r squared. So area is pi times half of 60. We just want the radius, so that would be 30. And that's to the second power. So pi times 3 threes are 9 with 2 zeros. And this is going to be 900 times 3.14 is 2826. Is that right? 900 times 3.14. Okay. And then we have to add these, because we're not taking a bite out, we're adding pieces on. So 2826 is going to be 6426 square feet. And we didn't have to round that one. It kind of took care of itself, but that's okay. Number 11. The figure below is 3/4 of a circle. And I've learned that when I see 3/4 in the word of, it's 3/4 times whatever follows. Find the area of the figure. So I'm going to find the whole circle and then multiply it by 3/4. So area of a circle is pi r squared. So area is 3.14 times 9 squared. So area is 3.14 times 81, and that's going to be 254.34, and it did not say to round, so I won't. So I'm going to bring that 254.34 in here for my circle and multiply it by 3/4. Now you can use 0.75 for 3/4, or you can multiply the fraction. It doesn't matter. That will give you 190.74. So the answer here is 190.74 square inches. If a square is drawn with the same area, what would a side of that square measure to the nearest inch? So here's what they're asking me. If we take a square, if only that were a square, let's pretend that's a square, and we give it an area of 190.74 square inches, we want to know what each of the sides are of this square. So we know that the area of a square is s to the second power, and we know that area is 190.74 because it equals that circle. And how do you isolate s according to algebra? You must take the square root. So s is approximately the square root of 190.74, and it says to the nearest inch, so 13.8 is going to round to 14 inches. So one of these sides, or all of these sides, because it's a square, is approximately, not exactly, but it's approximately 14 inches. I like those questions. I really like number 8.